Let's start with a quiz. Take king, subtract man, add woman. What do you get? It sounds like nonsense, but in the world of AI, this calculation has a real answer, and I'll reveal it in a minute. Here's another number to hold on to. Every time ChatGPT spits out just one piece of a word, a single token, around 350 billion calculations run behind the scenes. And almost all of them are something you learned in math class, matrix multiplication. Just rows and columns of numbers, multiplied together, over and over again. So how can pure multiplication produce language that sounds so natural, so human? Today, we're opening up the heart of AI and looking at it from the one angle that explains everything, the math. The first key is a mechanism called embedding, turning words into numbers. In 2013, Tomas Mikolov and his team at Google released Word2Vec, a system that converted each word into a list of 300 numbers, called a vector. And that gives us the answer to our opening quiz. Take the vector for king, subtract man, add woman, and the closest word to the result is queen. It's one of the most famous experiments in AI history. Think about what that means for a second. The meaning of a word can be manipulated with simple addition and subtraction. In other words, meaning itself exists as a direction in a space of numbers. The same trick works for countries and capitals, or verbs and their past tenses. And these lists of numbers have been getting longer every year, from 300 numbers in Word2Vec, to 768 in GPT-1, to 12,288 numbers per token in GPT-3. Every word you type is instantly turned into a point floating in a space with more than 12,000 dimensions. That's the raw material AI works with. So how does AI actually process those lists of numbers? In June 2017, 8 researchers at Google published a paper with a bold title, "Attention is all you need." This was the birth of the transformer, the foundation of virtually every modern AI. Its radical idea, throw away everything else, and build the entire network from simple, parallelizable operations. Now, open up a transformer and look inside. The attention mechanism, which decides which words to focus on. Matrix multiplication. The feed-forward layers that transform information. 2 matrix multiplications, sandwiched together. The embeddings we just talked about? 1 giant lookup matrix. As Andrei Karpathy put it, a typical neural network is basically a sandwich of just 2 operations, matrix multiplication, and cutting off at 0. An analysis of GPT-2 running on long text found that matrix multiplication accounts for 99.4% of all computation, everything else combined is roughly 0.6%. So what we call AI thinking is, quite literally, multiplying enormous tables of numbers together, again and again. So just how big are these multiplications? In May 2020, OpenAI unveiled GPT-3, a model with 175 billion parameters, the numbers used in all that multiplying, stacked into 96 layers. There's a well-known rule of thumb from OpenAI's own research: inference costs about 2 operations per parameter, because each one needs a multiply and an add. That means every single token GPT-3 generates costs roughly 350 billion calculations. If a human did 1 calculation per second, non-stop, day and night, that's about 11,000 years of work, for one piece of one word. And training the model was on another level entirely, 3.14 times 10 to the 23rd power operations. On a single GPU of that era, that would have taken 355 years in theory, at a cloud cost of around $4.6 million. That's why nobody trains these models on one chip, and why the hardware world was about to change forever. This multiplication gold rush ended up transforming hardware and the world economy. In 2017, NVIDIA introduced the Tensor Core, a circuit built into its GPUs that does exactly one thing: multiply small matrices at incredible speed. 5 years later, its H100 chip could perform about 989 trillion matrix operations every second, roughly 35 times more than the GPUs that trained GPT-3. And the market noticed. NVIDIA, at its core, a company selling matrix multiplication, hit a market value of $1 trillion in May 2023. By October 2025, it became the first company in history worth $5 trillion. 5 times bigger in just 2.5 years. One mathematical operation, taught in every linear algebra course on Earth, created the most valuable company in human history. And that brings us to the big question: can pure multiplication ever truly understand language? Believe it or not, this debate started 45 years ago. In 1980, philosopher John Searle proposed a thought experiment called the Chinese room. A person who knows no Chinese sits in a room, follows a rulebook to manipulate symbols, and produces perfect Chinese answers, while understanding nothing. His point: manipulating symbols by rules is not understanding. In 2021, linguist Emily Bender and Google researcher Timnit Gebru made the modern version of that argument, famously calling large language models stochastic parrots, systems that stitch words together based on probability, with no reference to meaning at all. That paper cost Gebru her position at Google, in a controversy that shook the entire AI industry. But Geoffrey Hinton, Nobel laureate and a godfather of AI, fires right back. In his words, "It's very clear that we understand language in much the same way as these large language models. Same math, two completely opposite conclusions." Let's wrap up with 3 takeaways. 1. Words become vectors, lists of numbers where meaning is a direction. 2. Over 99% of AI computation is matrix multiplication, nothing more exotic than that. 3. The scale is staggering, about 350 billion operations for every single token. And yet here's the honest truth: nobody has a complete theoretical explanation for why this works so well. Stephen Wolfram called it a potentially surprising scientific discovery. So now it's your turn. At the end of all this multiplication, is there real understanding, or just a very good parrot? Let me know what you think in the comments.